In got it number 1, we're asked to do the same thing, to find the roots or to find the zeros or to find the solutions of this particular equation, whether they are real or imaginary. I'm going to write real or imaginary here. It's really important you understand the different sets of directions. So your first step is you have to set this thing equal to 0. So I'm going to take this to the other side and this to the other side, changing their signs. So you have a positive x to the 4th, a positive 2x to the 3rd. Because you're moving the 13 over, it is now negative 13x squared, and you're moving the 10 over, it's now positive 10x, and that equals 0. I will definitely suggest here that you either A, add a 0 to the back of this, or B, take out a GCF of x, which is definitely the easier thing to do. If the problem has a GCF, please make sure you take it out. So we're going to get x cubed plus 2x squared minus 13x plus 10. We know, because we have this floating x outside, that one of our zeros is 0, no matter what. So what we're going to do is we're going to focus on this inside part when we do our rational root theorem. So for our rational root theorem, we're going to do plus or minus 10, 5, 2, and 1, because that's what goes into 10, over the factors of the first leading coefficient, which is just a 1. I'm going to put this in my calculator under my y equals. Note, you could put, by the way, you could put this equation in there, or you can put this equation in there. It won't matter. If it's a 0 in this equation, then it's a 0 in that equation. I like to put the first equation in there because then I can verify my first 0 had. So I'm going to type x to the 4th plus 2x cubed minus 13x squared plus 10x. I then hit second and graph to get my table feature up. Let me see if the light helps here a little bit. I'm going to verify that 0 was in fact a 0, so when I type 0, hopefully I will get 0, which I do. Now I'm going to test a positive and a negative 10. Neither of those give me 0 for my y value. Now I will test positive and negative 5. I do get a 0 at negative 5, so I'm going to write x equals negative 5 because I know that that is a 0. I'm going to test 2 and negative 2, and I do get a 0 at 2. So I'll write comma 2 here. Not negative 2, but positive 2. Now I'm going to test 1 and negative 1, and I do get, right here, I get positive 1 yields a 0, so I will write it here. Here's the great news. This was a cubic, or I should say this was an x to the 4th problem originally, right? Well, the good news is we found out right away that x equaled 0 from our GCF, and then we found the 3 others right away, negative 5, 2, and 1. Guys, that is 4 separate answers. I should say maybe even 4 solutions might be a better way of saying it. So I know because it was an x to the 4th, I don't even have to do synthetic division because they're all there. No synthetic division needed. They were all rational, which makes this problem very, very easy. Let's do the second got it. When we do the second got it, they're asking us for these particular zeros now. So we're going to set this equation equal to 0. And we're going to do, I don't see any GCS I can take out, so we will do plus and minus the back number of 6, 3, 2, 1, because those are the numbers that go into 6, over plus and minus this coefficient, which is 1 and 2. So this one has more things to test. I'm going to type the equation into my calculator. Let's see, 2x to the 4th minus 3x to the 3rd. Minus x minus 6. Now, if you don't have one of these calculators, you can sit here and plug all these in. It just takes a little longer, but it is doable. Oh, well, what's kind of nice, look, guys, a couple of my zeros already pop up. See, at negative 1, I know that's one of my zeros. And what else pops up? 2. So I may as well just put those on there. But I'm going to test all the other ones, too. So I'm going to test positive and negative 6. I know that's hard for you to see. There's a good spot. Positive and negative 6 do not work. Positive and negative 3 do not work. Positive and negative 2. We already have positive 2. Okay, positive and negative 1. We already have negative 1. So now I have to test things like 3/2 and 1/2. So I'm going to test 3/2 and negative 3/2 and 1/2 and negative 1/2. Neither of those work. Now maybe you're wondering, why are you testing 6/2? Well, 6/2 is a 3, so I don't have to test 6/2. Maybe you're wondering, why aren't you testing 2/2? That's because 2/2 is a 1, and I already tested 1. So the only 2 that I found are these 2 right here. These are my rational roots. But the good news is, we know we have an exponent of 4, so there's going to be 4 total altogether. Please remember, by the way, to always set things equal to 0. All right, we're going to do synthetic division with my rational exponent. So I'm going to put a negative 1 in the box, and I'm going to list all of these over here. So I have a 2, I have a negative 3. Hopefully you know I have a hidden 0x squared. So I need to put a 0, and then I have a negative 1 and a negative 6. Now it's time to do synthetic division. Drop down the 2, multiply, add, multiply, add, multiply, add, multiply, add. And you always need to get a remainder of 0, and if you don't, you did it wrong. Try it again, go back, check your equation in your calculator, or check your synthetic division. Now I'm going to do synthetic division with this 2 right here. So I'm going to put 2 in a box. I'm going to carry down these numbers that I just got. They're my new equation. And do synthetic division with those new numbers, not with the 0. Carry down the 2. And maybe you want to draw arrows so when you do your notes, when you do your homework, you know where those numbers came from. I didn't just make them up. Okay, drop down the 2, multiply 4, add negative 1. Multiply negative 2, add 3. Multiply 6, add 0 for your remainder. If you don't get 0, you did something wrong. At this point in time, that's as much synthetic division as possible, so I'm going to put this into an equation now. So here goes the equation. The plus 3 is my constant in the back, and then I work my way up. This negative 1 gets an x, and this 2 gets an x squared. Remember, we have set everything equal to 0, so we're going to set this equal to 0. You can try to factor this. You are more than welcome to try to factor. I personally like to do the quadratic formula with this. So I'm going to do negative b, which is 1, plus or minus the square root of. B squared would be a positive 1, minus 4 times a is 2, c is 3, all over 2 times a is 2. And if you like to try to factor, you're more than welcome, but typically if they're not rational roots, it's not going to factor unless you did something wrong with your rational roots. So it's just a safe step to go straight into your quadratic formula. So that's 1 plus or minus the square root of, let's see, negative 23 all over 4. 824. And now the only thing I need to do is, what can I pull out of negative 23? The only thing I can pull out of my square root, I don't have any perfect squares inside of 23, so just an I. So we're going to have 1 plus or minus I square roots of 23 all over 4. Those are my 2 other x values. If you want to write all 4 of them, which is always a good idea, all of your answers are going to go over here. We have 4 solutions, and those solutions are x equals negative 1 from up top, x equals 2 from up top, x equals 1 plus I square roots of 23 over 4, and last but not least, 1 minus I square roots of 23 all over 4. And so 2 are what we call, these 2 up here are what we call rational. These ones are imaginary solutions. If you look at the graph down here, I believe it goes, I think it should go up here with this particular thing. Let's make sure we talk about this in class together, whenever we get together in class. I do believe that picture is supposed to be up there.